Greetings. My name is Brandon Thompson. I'm a CTE ISS here at headquarters in Alexandria. And today I'm going to be taking you through building your Pi computer for Coding 2. So I have a few things here with me to start out with. First, I have my toolkit. If you have the full cybersecurity program, you should have these toolkits in your school by now. From this toolkit, I have my long nose pliers, side cutting pliers, and a number 1 Phillips screwdriver. Also with us, I have a anti-static wrist strap with the cord, my anti-static mat, and some safety glasses. My glasses are impact resistant, so I will not be wearing these today, but if you don't have impact resistant glasses, you should probably wear some safety glasses, just because we are using tools and doing some cutting and things. Also, in front of me, I have our Pi case, LCD touchscreen, the Pi keyboard and mouse that we'll use a little bit maybe toward the end. I have various components for our Pi case, covers and ancillary pieces there. And I went ahead and grabbed the sensor kit extension board as well, because I want to show you how that attaches also. Other than that, we have some screws and various components that came with your case. Now, I'm not sure what your case looked like whenever you took it out of the box. My stuff went to IT first, and they played around with it and tested everything on our network before I got it. So I'm going to be working from the case as I have it here. If yours looks a little different, just know it should be the same general layout. It just may be put together a little different up front. So let's get ready to begin. Take off anything metal. We are working with electronics. Don't want to have anything that conducts that could get hot on us and cause damage to ourselves or to the equipment. We're going to connect our wrist strap snap and then connect the wrist strap to our anti-static mat. This just prevents any buildup of static electricity, and our mat is grounded through the table and its connection. So let's begin first. You have your micro SD card, and here it is up close if you need to see it closer. This is preloaded with our operating system, which is Noobs. And before we begin assembly, we're going to start off by inserting it in the SD card slot. Make sure that's seated. The contacts do go toward the board, so make sure you turn it the right way. And then that is done and out of the way before we get started. Otherwise, if you wait till after you put it in the case, you will not be able to access that card slot. So let's do that first. A couple of things to note on the board here. We do have our input-output pins that will need to be available for our sensor kit as we connect things. So keep that in mind. We do have some connectors here that use a pull-up lock. So you pull it up to release the cable, and then push it back down once the cable's in place to firmly attach it. You'll notice the edge of one of these is broken. These are plastic, and they will break if you apply too much force. So please be careful with those and encourage your students to also. And as with any soldered circuit system, you know, there are some sharp contact points and things on the back, so just be careful as you're handling this to not prick fingers and cut yourself and things like that. So let's begin. I'm going to set the Pi computer to the side, and let's look at the case a little bit first. So on our case, we have 4 screw points that will hold our LCD screen, our touch screen, to the case. And you can see here are the 4 points, plus you have the ribbon that attaches to your Pi. You will also note that there is a power port right here that uses micro USB, and we will be attaching that as well. So let's take and place our case on top of our LCD screen. You're going to feed the ribbon through the slot into this compartment, which is where our Pi computer will eventually sit. And you want to line up the screw holes with the screen. Now you'll notice that you have to kind of push a little bit on this case at least to get the screen to sit in flush. You want to make sure it's flush before you try to put the screws in, or else it will cross thread. So we're going to put the screws in, and these are fairly tiny screws. If you drop them, they can be difficult to retrieve. I thought I had lost one of them yesterday. Luckily, I found it whenever they came to vacuum before it got sucked up. I will be honest with you, there is no really good way to drop these screws in without them turning over on you. So it just takes practice and patience. Okay, now that our screws are in, our next thing that we're going to do is take our Pi computer and we're going to place it in the case with our USB ports and our Ethernet port toward the outside where you'll see the gap for the camera. Before we put the Pi in place for its final portion there, you insert the ribbon cable into this connector. Remember, you have to lift up the black friction connector before you put the cable in. Once the cable's in place, you will push the black connector back down. Yours should not come out like mine does. Once our cable's in place, it should be firm and not pop out when you pull on it. So now we're going to take some of these really small nuts and we're going to place them each here on a screw to hold our Pi in place. Now if you are going to use the fan or the top bracket, in theory you don't have to place the nuts on because the pegs here are long enough to hold the Pi firmly down. My fear with students using it is that as they open this up and down to see how everything works and to take a look at the Pi inside, that the Pi will become loose and fall out and become damaged. So I highly recommend using the nuts to firmly secure the Pi in place. Once you have the nuts in place, you can use your long nose pliers to secure them firmly to the board. If you are using the nuts to secure your Pi to the case, then one thing I found helpful to make the covers fit properly is to take your side cutting pliers and remove approximately 1/8 of an inch from each of the standoffs here. And that allows for the nut space to not force the cover open all the time. Whenever I tried it without shortening the legs, the cover would pop open randomly, which I wasn't a big fan of. Now we did not purchase the cameras for these for a variety of reasons. Some of which involve privacy and legal and all that sort of stuff. So what you'll want to do is put in the blank that doesn't have the hole for the camera. You can see this one has the hole, this one doesn't, and this will keep unwanted dust and things out. To do that, you just take, and you'll see here you have space. You're just going to take and press that in. And then you take these two small black screws. And screw those in to the two holes to secure that in place. Now if you're going to be having students do an activity where they're just using the touch screen and they're not going to be adding any sensors or anything, you can use the fan cover You can attach the little fan there. It has 2 wires that plug into the input-output ports, and you just snap that in place. For most of our activities with these Raspberry Pis, where we're going to be using the sensor GPIO extension board, you will want to use the one that allows your GPIO pins to be accessible. It comes with a cutout in place. I just took a flat screwdriver and pried it up, and then I cleaned up all the connections with the side cutting pliers to give us a nice smooth work surface. If you had a little sandpaper, that would probably be beneficial as well, to come in with that sandpaper and just smooth that off. But you just take your cover of choice, you slide it in the slots, and then snap it into place. If you want to add the stand for your now assembled Raspberry Pi tablet computer, you can do so. You just take the stand base and add it to the mounting brackets. Takes a little doing, but you can get it lined up. And then you have your screw and nut. It's already pre-molded to where the nut fits. You don't need a wrench on the back of it, which is kind of nice. But you just hold the nut in place. And then run the screw from the outside. Here you have your assembled Pi computer. Now, if we're ready to check and see if we have power, there are 2 Ys in your case box, 2 of these Y power cables. The one you're going to want has the USB-C and the micro USB. So the micro USB goes to your screen. It just plugs in underneath. And then USB-C attaches to the power port on your Raspberry Pi. And to test functionality, we take a power cable that's plugged in to our power source. You should have gotten the appropriate power connection for the wall plugs in your region. And then you'll see it begins to boot up as such. Now we can use it just like this as a fully functioning computer with touchscreen, or we can use the USB mouse and keyboard to provide additional functionality utilizing the USB ports on the side. When we're ready to begin our lab activities using our GPIO ports, you attach your ribbon cable to your extension board, attach the extension board to your breadboard, and then you just plug this into the GPIO ports on your Raspberry Pi, which are now accessible through the case. So hopefully that will get you through the basic assembly of your Raspberry Pi computers and help you to be prepared and confident to embark on this journey with students. A few other notes that I would like to share dealing with the use of these. They are approved for use on DoDEA's network, so you can plug them into a network cable for downloading updates and software and things like that. If you do not want to plug it into your network in your school for whatever reason, if you have the cybersecurity pathway, you should have these encrypted hard drives that are USB that you can download software packets to the hard drive and then take the hard drive and plug it into your Raspberry Pi using the USB cable. Whenever you are not using these with students in a supervised capacity, they should be locked away. Officially, this is considered a hacking device, and we do not want students to inadvertently cause harm to our networks or any other systems while using these for purposes other than specified within the course. So thank you so much for your time. Feel free to reach out to me with questions. My name again is Brandon Thompson. I am here at headquarters, and thank you.